Punta tayo dito. So, the roof of an industrial building consists of trusses having configuration such that the purlins are placed at nodal and mid-panel points as shown dito. So, meron tayo dito ang purlins. Ayan. So, it is placed at nodal points saka sa mid points. So, mga nodal saka sa mid na. And then, the span of the truss is 12 meters as given. Trusses are supported on an 8-meter high na column, spaced 3 meter on center. Corrugated GI sheets are to be used as a roofing materials. So yung weight ng corrugated GI sheets is 0.125 kPa of the plan area. Yung sa bracing is 0.015 kPa of the plan area. Yung sa purlins is 0.12 kPa of the plan area. Yung approximate weight ng truss is 50 plus 10 times L over 3 in Pascal, where yung L is the span of truss in meters, which is itong 12 meters. And then we approximate the roof live load, which is 0.75 minus 0.02 multiplied by theta minus 10 in kPa, where theta is itong roof slope in degrees, itong 30 degrees. So, itong warehouse na to is, meron siyang standard occupancy, category 4, meron siyang basic wind speed na 260 kPa, exposure category type C, rigid building, so yung G niya is 0.85, enclosed building, GCPI is plus minus 0.18. So, it is to be built on an open flat terrain, so meron siyang topographic factor na 1.0. Yung structure type niya is mean wind force resisting system or MWFRS. Yung directional factor niya is 0.85 as referred to table 207A.61. Yung velocity pressure is defined by this formula. We have 0.613 kZ, kZt, kd v squared in Pascal, where v is in meter per second. And then meron siyang design wind load, which is again defined by this formula, QGCP minus QIGCPI. So, yung details nung roof truss natin, kasi yung dulo nito is i-analyze natin yung roof truss. So, considering the gravity loads, yung dead load tsaka wind load, and gravity loads tsaka live loads. So, dead load tsaka live load, and itong wind loads. So, meron siyang 400 mm dito, 400 mm, and then at L over 3. No? So, kung meron kang span na 12 meters divided by 3, so 4 meters, 4 meters, 4 meters. So first, we need to compute yung gravity loads. So yung weight ng corrugated GI sheets is 0.125 kPa of the plan area. So this includes yung mga lap connectors, yung mga nails, etc. Yung weight ng bracing natin is 0.015 kPa again of the plan area. Yung sa purlins natin is 0.12 kPa of the plan area. So this includes yung mga sagrads, yung mga washer, yung mga clips, etc. Yung approximate weight ng truss natin is 50 plus 10 L over 3 in Pascal. So yung length natin is 12 meters. So 50 plus 10 times 12 divided by 3, naka-Pascal to, we divided by 1,000 to make it in kPa. So we have 0.09 kPa. So meron na tayong total dead load ngayon. So ito yung sa 0.125 plus 0.015 for the bracing. For the purlins, 0.12. And for the approximate weight ng truss is 0.09. So we have 0.35 kPa. And for the approximate roof live load, we have 0.75 minus 0.02 times the roof slope, which is 30 degrees, minus 10. So we have 0.75 minus 0.02 times 30 minus 10. So we have 0.35 kPa. So ito lahat is with respect to plan area. So bali kung i-visualize natin yan, yung mga gravity loads. So that is acting on the horizontal projection, yung roof surface natin. So ito yan. So ito yung meron tayo ditong dead load na 0.35 kPa and the service live load na 0.35 kPa. So, for gravity loads, for the dead load, and for the live loads, meron tayong 0.35 kPa and 0.35 kPa. So, kung ano yung, pag mag-a-analyze na tayo ngayon ng thrust, so kung ano yung mga forces na makukuha natin for the dead load is the same forces na mag-a-act dito for considering live load. Kasi pareho sila ng demand. Punta tayo dito sa wind load naman. So, yung location nung warehouse natin is andito. This layer. So, somewhere dyan. So, may Rizal na. So, meron tayong mga wind zone dito. So, depende dito sa mga lowers. Ito yung pinaka-lower wind velocity. Then, dito yung pinaka-maximum velocity. Itong 320. Kasi may tatlong map tayo, na wind map. So, for occupancy category 1, 2, and itong combine, 3, 4, and 5. So, yung occupancy category natin is standard occupancy. So, under lang siya sa category 4. So, ito yung kukunin natin na graph. So, again, it is divided into these different wind speed. So, itong 220 to 240, ito yung mga low wind speed. Itong mga 250 to 280, so mga medium. Then, ito yung mga maximum na, 290 to 320. So, anyway, yung location natin is, andito siya nag-fall. The chart. So, meron siyang wind velocity na 260 kph. Anyway, that is given sa problem. So, yung kailangan natin is naka-meter per second. So, we just need to convert that one into meter per second. So, by just dividing 8 by 3.6, so we have 72.222 meter per second. So, meron tayong basic wind speed na 260 kph or 72.222 meter per second. So, bali dito sa warehouse natin, so meron tayo dito sa windward side, dito nag-blow yung wind natin. So, at a speed of 260 kph or 72.222 meter per second. And yung concern natin dito is ma-compute natin yung mga velocity pressure and then makuha natin yung mga design wind load. So, for the dito na part, sa windward side, okay? And then, dito din sa leeward side, yung sa kabilang side. And also for the side walls, dito. So first, we need to compute for the velocity pressure. So it is defined by this formula, 0.613 kz, kzt, kd v squared in Pascal, where v is in meters. So yung basic wind speed natin is, again, na-compute na natin, 72.222 meter per second. And then yung directional factor natin, again, as defined in table 207A.61. So meron tayong directional factor na 0.85 na kasi given yung structure type natin na mean wind force resisting system. So bali ito yan. So ito. MWFRS 0.85. So yung KZT, ito yung topographic effect. So since ilalagay lang natin siya sa flat terrain, so automatic yung KZT is 1.0 pag flat. And then yung KZ natin, so we have, again, just defined sa NSCP, 2.01 multiplied by Z over CG, raised to power of 2 over alpha. So dito yan, sa 2015 na NSCP. So the velocity pressure exposure coefficient KZ may be determined from the following formula. So pag within siya sa 4.5 mg to Zg, so yung Z mo, so ito yung gagamitin mo na formula. And then, pag less than siya sa 4.5, so ito naman yung formula na gagamitin mo. So makikita mo na pinaka-minimum Z is itong 4.5 na. Okay? Kasi hindi na Z yung nilagay niya. Talagang 4.5 na talaga. So bali kung Z mo is mga 1 meter or 2 meter, so 4.5 pa rin yung gagamitin. So minimum Z is itong 4.5. So to compute itong mga, to get itong mga Z, G, tsaka itong alpha, andito yan sa table 207A.91. Ito yung mga terrain exposure constant. So yung exposure category natin is type C. So ito yan. So meron tayong alpha na 9.5 and meron tayong ZG na 274.32. So bali gagamitin natin itong formula na to pag within siya dito sa range na 4.5 tsaka itong 274.32 meters. So, klaro man din dito na for buildings with H, yung height niya is less than sa Z minimum, which is itong 4.5. So, Z shall be taken as Z minimum. So, parang ito pa rin. So, 4.5 talaga yung gagamitin. So, bali yung key Z natin ngayon is magiging 2.01 times Z over 274.32 raised to power of 2 over 9.5. So, meron na tayong QZ, which is 0.6613 KZ. So, KZT is 1, KD is 0.85, velocity is 72.222 squared. So, ito naka-Pascal to. So, we just divide it by 10 to the power of 3 para maging kPa. So, meron na tayong 2.7178 KZ, kPa. So, ngayon, gawa natin to ng before that, we calculate the mean roof height, yung H. So, ito yung building natin. And so meron siyang 8 meter high na column, then 12 meter na span ng truss. No? And this is 30 degrees yung roof slope. So we just need to take itong sa middle nito. So kalahati ng 12 meters, we have 6 meters, 6 meters. And then dito naman, considering itong triangle, so we have 6 tangent 30 degrees. So, dito yung mid niya, na bali kalahati nitong 6 tangent 30. So, 6 tangent 30 degrees divided by 2. So, dito yan. So, yan yung concern natin. We just need to compute for the value of the mean roof height, yung H. So, again, it is defined ito sa notation ng NSCP 2015. So, ito yung H, yung mean roof height in meters, except that the eve height shall be used for theta less than or equal to 10 degrees. So, yung roof slope natin is 30 degrees. So, yung mean roof height yung gagamitin natin. So, meron tayong eve height dito na 8 meters. So, 8 meters plus kalahati nitong 6 tangent 30. So, we have 9.732 meters. Ito yung H niya. So, we need to tabulate the value of Z, KZ, and QZ. So, again, we start from the minimum, which is 4.5 meters. Next is 6 meters. Then, next is itong eve height na 8 meters. And then, up to H, which is 9.732 meters. So, may value tayo ng Z. We just need to substitute that one dito sa formula natin for KZ. So, we have 2.01 times 4.5 over 274.32 raised to the power of 2 over 9.5. So, we have 0.846. 2.01 times 6 over 274.32 raised to the power of 2 over 9.5. So, we have 0.899. And then 2.01 times 8 over 274.32 raised to the power of 2 over 9.5. So, we have 0.955. And 2.01 times 9.732 over 274.32 raised to the power of 2 over 9.5. So, we have 0.995. So, may value na tayo ng KZ. So, we just need to substitute that one dito sa QZ natin. So, we have 2.7178 times 0.846. So, we have 2.299 kPa. And 2.7178 times 0.899 is equivalent to 2.443 kPa. And 2.7178 times 0.955, so we have 2.595 kPa, and 2.7178 times 0.995, wait lang, 955, it is 995. So we have 2.704 kPa. So ito yung QH natin, no? Kasi yung Z dito is in terms of H. So ito yung QH. So may QZ na tayo, so we can now calculate for the design wind load. It is defined by QGCP minus QI GCPI. So itong first term, this with respect to external pressure, well, considering yung mga external surfaces, well, itong I naman, ito yung referring to internal pressure. So considering naman yung mga internal surfaces. So under dito sa NSCP 2015, so under dito sa 207 B.4.1 for enclosed and partially closed rigid building. So yung design wind pressure for the MWFRS of buildings of all heights shall be determined by the following equations. So ito yan. So makikita natin dito na yung QI, ito siya, ito, is equivalent to QH for windward walls, side walls, leewards, and roof of enclosed building, and for negative internal pressure evaluation in partially enclosed building. And also makikita din natin na kahit hindi siya negative internal pressure, kahit positive internal pressure evaluation, yung QI may be conservatively be evaluated at height h. QI equals QH. So bali yung QI dito magiging QH na. So again, given sa problem, meron tayong rigid building. So sa rigid building, automatically yung G is 0.85. Yung G is the gas effect factor. Okay, so makikita mo yan sa section 207A.9. And then for enclosed building, yung GCPI natin is plus minus 0.18. So dito yan sa table 207A.11.1, itong internal pressure coefficient. So under yan sa enclosed building, so ito yung gagamitin natin na GCPI. So yung plus, kasi nandito sa notes, yung plus and minus sign signify pressure acting toward and away from the internal surface respectively. So pag plus ka, that is towards the internal surface, and pag minus ka, that is away from the internal surface. So ngayon, yung formula natin is magiging Q multiplied by 0.85 Cp minus QH, kasi yung QI is QH, plus minus 0.18. So we just need to substitute the value of QH, which is itong 2.704. So, and then we calculate this one. So we have 0.85 of QCP. So negative multiplied by positive, that is negative. So, and then negative multiplied by negative, magiging positive. 0.48672. So yung two cases shall be considered to determine the critical load requirements. So again, may dalawang value tayo dito. So meron kasi tayong force condition at suction condition. So yung critical lang yung gagamitin natin for the design. So, bali considering itong internal ng mga surfaces natin. So, pag yan is towards the internal surfaces. So that is a worse condition. So, meaning, yung plus yan, yung plus 0.18. So, kung negative times positive, that is negative. So, if we use negative sign dito sa formula natin, so we are considering the burst condition. So, bali considering yung GCPI na plus 0.18. And then, pag away siya sa internal surfaces natin, so that is a suction condition. So, meaning we are considering the negative 0.18, which is away from the internal surfaces, or negative times negative, that is positive. So, if we use positive sign dito sa formula natin, so we are considering the suction condition. So, considering yung GCPI na negative 0.18. Okay, so ngayon, consider muna natin itong windward wall. So, ito yan, windward wall. So, the wall pressure coefficient, CP, so for the windward wall, so yung L over B for all values, yung CP is 0.8. And then, we're going to use QZ. So, bali, for different value of Z, so makukuha natin yung mga QZ, and also yung CP, which is 0.8. And then, yung pressure natin is ito. So, ito yung nakuha natin na design wing load. So, we have 0.85. So, ito magiging QZ na. And then, CP minus plus 0.48672 kPa. So, for different value of Z, so meron tayong sa 4.5, sa 6 meters, 8 meters, ayan. Okay? Hindi kasali yung QH. So, kasi sa wall lang tayo, So, hanggang 8 meters lang. Kasi dito lang yung wall. So, may na-compute na tayong QZ, yung kanina. So, ilagay lang natin dito sa table. 2.299 kPa, 2.443 kPa, and 2.595 kPa. So, na-compute na natin to kanina. So, pwede nyo balikan yung portion na yan. And then, yung CP is andito yan sa table. So, we have 0.8. So, 0.8 to lahat. So may QZ ka, may CP ka, so you just need to substitute that one dito. So we have 0.85 times 2.299 times 0.8 minus plus 0.48672. So therefore we have 1.0766. So considering the minus, so we are considering the worst condition. If we use plus, so we have 2.05 for the suction. So bali ito yan, na portion. So at a distance of 4.5 meters. And then 0.85 times 2.443 times 0.8 minus plus 0.48672. So if we use minus, so we get 1.175 for the first condition. And if we use plus, we have 2.148 for the suction condition. So bali up to 6 meters. So ito yan. And then 0.85 times 2.595 times 0.8 minus plus 0.48672. So we have, if we use minus, so we have 1.278 for the burst. And if we use plus, so we have 2.251 for the suction. So bali, hanggang dito na yan sa egg height. So 8 meters. Next is dito sa leeward wall. Is a leeward wall. So again, meron tayo ditong table from NSCP 2015 for the leeward wall. Ito yan. So meron tayong different value for L over B. So it ranges from 0 to 1, 2, and greater than or equal to 4. And then we have this different value of CP. And then we're going to use QH. So yung L tsaka B is dito yan sa notation again. Ang footnote niya. So we have B is the horizontal dimension of the building measured normal with the wind direction. So ito yung wind direction natin. Normal sa kanya, meaning yung perpendicular distance sa kanya. So ito siya. And then yung L is the horizontal dimension of the building measured parallel. So kung ito yung wind load natin, so yung length parallel sa wind direction. So parallel sa kanya. So ito yan. So bali ito yung L, and then ito yung B natin. So, bali, yung L over B natin is 12 divided by 12. So, we have 1.0. So, meaning, andito yan. Okay. So, thus, yung CP natin is negative 0.5. By the way, we are permitted to use linear interpolation for this. Okay. Again, andyan yan sa footnote. So, CP is negative 0.5. So, ngayon, yung magiging formula natin, since we're going to use QH, so magiging QH siya dito. Multiplied by CP minus plus 0.48672. Okay, so we have 0.85 yung QH natin. Again, na-compute na natin to kanina. 2.704 times negative 0.5 minus plus 0.48672. So if we use minus sign, so we have, we'll get negative 1.636 for the worst condition. And if we use plus, we have negative 0.662 for the suction condition. So bali dito yan. So negative sign meaning away siya sa surface. So it could be dito is 1.636 or for the burst condition and 0.662 for the suction condition. Next is itong sa sidewall, bali yung dito. So again, referring to this table for the sidewall for all values, so yung CP is automatically negative 0.7 and we are going to use QH. So thus, yung CP natin is negative 0.7 and then we're going to use QH. So we just need to substitute the value of QH. We have 0.85, yung QH natin, na-solve na natin ito kanina. We have 2.704. CP is negative 0.7 minus plus 0.48672. So we have negative 2.096 for the worst condition. And if we use plus, we have negative 1.122 for the suction condition. So bali dito yan. So again, negative sign meaning away sa surface natin. So ito yan. Tsaka dito sa kabila. So this one should be 2.096 kPa for the burst condition. And for the suction condition, so this should be, yung magnitude nito is 1.122 kPa. Okay, so may H tayo dito na 9.732 meters. So, considering naman dito sa roof pressure, no? So, ito yung table natin sa NSCP 2015 for the roof pressure coefficient, CP, for use with QH. So, we're going to use QH for the design wind load. So, yung slope natin is 30 degrees, 30 degrees. So, we'll be using itong normal to ridge for theta greater than or equals 10 degrees. So, ito yan, yung mga values. So, we have dito sa windward tsaka sa leeward. And then, meron tayo ditong H over L, no? Na ratio. So, dito sa notation, yung H tsaka yung L. So, yung L, again, is the horizontal dimension of the building measured parallel dito sa wind direction natin. So, ito yung wind direction natin. So, ito yung length parallel sa kanya. And then, yung H is the mean roof height in meters. Ito yun. Yung compute natin kanina. 9.732. Except that the eve height shall be used for theta less than or equal to 10 degrees. So, since this is 30 degrees, so we'll be using the mean roof height na 9.732. So, bali, yung H over L natin is 9.732 divided by 12. So, we have 0.811. So, meaning we will be using this one, kasi in between siya sa 0.5 tsaka 10. So, mag-i-interpolate tayo dito. So, since may roof slope tayo na 30 degrees, so, kasi meron tayo ditong different angle, no? So, itong 30 degrees yung kukunin natin for the windward side. And for the leeward side, itong greater than 20 degrees. So, dito sa leeward side, very expected na negative 0.6. And then, dito sa windward side is mag-interpolate tayo. Itong positive sign na 0.2, so this should be expected 0.2. So, I think mas maganda kung itong negative sign na yung kunin natin. Negative 0.2 and negative 0.3 para mas malaki yung CP na makuha natin. So, makikita natin again sa footnotes, no? Or sa notes na linear interpolation is permitted for values L over B, H over N. Interpolation shall only be carried out between the values of the same sign. So, if we're going to consider the negative 0.2, so dapat yung kasama niya is itong negative 0.3. Where no value of the same sign is given, assume 0.0 for interpolation purposes. So, interpolation for intermediate ratio of H over L in this case shall only be carried out between CP values of the same sign. So, bali, if I'm considering negative 0.2, so yung kasama niya is negative 0.3, or itong 0.2, so yung kasama niya is itong 0.2 rin. So, anyway, ito lang yung kukunin ko. Okay. So, for the windward pressure, yung dito na side, so we need to calculate for CP by linear interpolation. So, I'll be considering this one, itong negative sign. So, kukunin ko yung sa 0.811. No? So, ano yung CP dito? Kasi ito yung nakuha ko na H over N. So, we have 10 minus 0.5 all over sa 0.811 minus 0.5 is equivalent itong negative 0.3 minus negative 0.2 all over itong CP minus nung negative 0.2. So, we'll get CP which is negative 0.203. So, may CP na tayo for the windward wall. So, again, balik tayo dito sa pressure natin. So, yung CP natin is for use with QH. So, bali, yung design wind load natin, yung Q should be QH. So, ito yan. So, again, we have this value for QH. Nasolve natin to kanina. So, we have 0.85 times 2.704 times negative 0.203 minus plus 0.48672. So, if we use negative sign, so we get negative 0.953 for the first condition. And if we use positive sign, so we'll get 0.0201 for the suction condition. And so bali ito yan. So, meron siyang negative sign, so away sa surface. So, kung positive sign, baliktad yan. Okay? So, ito siya is 0.953 kPa. Okay. Okay. So, we have negative 0.953 kPa for the burst condition. Next is itong sa leeward roof pressure. Yung sa kabilang side naman, no? Yung sa leeward. So, yung CP is, nakita na natin ito, no? Nakuha na natin to dun sa table. We have negative 0.6. So, bali, again, yung QH yung gagamitin. So, 0.85 times 2.704 times negative 0.6 minus plus 0.48672. So, we have negative 1.866 for the worst condition and negative 0.899 for the suction condition. So again, negative sign meaning away sa surface natin. So mali ito yan. So ito na yung negative 1.866 kPa for the burst condition. So kung burst condition, make sure na burst condition lahat. Pag suction condition, make sure suction condition lahat yung consideration. So yung wind load pressure natin for the burst condition, tsaka yung sa suction condition, so meron yan, no? Yung sa mga windward, so we have 1.076, so parang summary na to. And then sa 6 meter na height, so 1.178 kPa, and then for 8 meter high, 1.278 kPa. And then sa leeward, we have 1.636 kPa. So, pwede mong i-replay yung previous video na para makita mo yung kung saan galing mo. So, anyway, na-compute na natin to kanina. So, this is just the summary. And then sa roof pressure naman for the windward, so we have 0.953 kPa. Negative yung nakuha natin, so that is away sa surface. Yung sa windward, positive lahat yan, so towards the surface. Yung leeward is negative, so away sa surface. And then for the leeward na roof side, so again, that is negative yung nakuha natin, so that is away sa roof. 1.866 kPa. For the suction naman, so again, meron tayong mga windward dito. For different height, 2.05 for 4.5 meters, 2.148 for 6 meters, and 2.251 for 8 meters. So lahat yun positive, so that is towards dito sa surface. And then for the suction side, nakuha tayo na negative 0.662, so negative sign indicate that is away sa surface natin. And for the roof, yung sa suction side nakuha natin is positive, so that is towards the surface. So we have 0.0201 kPa. And then we have negative, no? Again, away sa surface natin, which is 0.892 kPa. So ito yung mga wind pressure natin. So next natin gagawin dito is i-combine natin itong windward at leeward, no? Para makuha natin yung total, yung sa whole pressure. So i-combine natin yan. Ayan. Okay? We need to combine this one. So, bali yung value ngayon dito is 1.0766 plus 1.636. So, we have 2.713 kPa. Okay. And then dito naman is 1.178. So, bali dito blank pa na. No? Bali, dito na lang lahat. So, 1.636 is equivalent to 2.184 kPa. And dito naman is 1.278 plus 1.636. We have 2.914 kPa. So, ganun din dito, no? For the suction side, 2.05 plus 0.662. So, we have 2.712 kPa. Kung makikita mo, sobrang halos, kunti lang yung diferensya. No? So, bali dito, we will be using 2.7 for our warehouse. And then dito is 2.148 plus 0.662. So, we have 2.81. No? So, makikita mo, kunti lang talaga yung diferensya. So, you can use 2.8 kPa for that one. And then dito naman is we have 2.913 kPa. 2.251 plus 0.662. So we have 2.913 kPa. It is 2.914. So it's up to you. No? So you can use 2.9 or you can use itong bigger value. No? So 2.914, 2.814, and 2.713. So yun na. No? So nakuha na natin yung mga gravity loads, yung wind pressure, yung sa wind load. So next natin gagawin dito is we need to convert this one into nodal loads para ma-analyze na natin itong thrust. Okay, so that would be sa next natin na video. So if you like this video, consider subscribing to my YouTube channel and you can also follow my Facebook page. Notify ka no, for my new videos. Okay. And it's free. No? So thank you for watching.